9.4, factoring to solve quadratic equations. We're going to be using the zero product property today. And we're going to be using the factoring that we learned in the last chapter. All right, so, move this out of the way. All right, remember when we factored polynomials, we found factors. Those things that were in the parentheses were called factors. We will now take those factors and find the solutions to the equations. So the first thing you want to think about, give you an idea of where we're going, is what values would make this equation true. So in other words, what number could you put in for x that would make this equal 0? Okay, let's try looking at 4. If we, let's get a color here. All right, if we had 4 and square that, minus 4, does that equal 0? All right, 4 squared is 16. 16 minus 4 does not equal 0, so no, that did not work. All right, let's try another one. How about negative 4? Negative 4 squared minus 4. Does that equal 0? Well, anything squared, whether it's positive or negative, is going to be a positive answer. So this would still be 16 minus 4, and that does not equal 0. All right? All right, let's try 2. If we put in a 2, square that, minus 4, does that equal 0? 2 times 2, which is what 2 squared is. 2 times 2 is 4. 4 minus 4 it does equal 0. So 2 works. All right? And then let's try the last one. Make sure you use parentheses if you're not sure about those negative things when you're squaring. All right? Negative 2 times a negative 2, which is the same thing as negative 2 squared, is 4. 4 minus 4 is 0. So yes, these two work. Okay? So those two answers are going to be the solutions to the equation. Okay? So we're going to take the factors and find those solutions. Quadratic equations can be solved by using the zero product property. So what we'll do is we're going to be given an equation. It's going to say solve. That means we're going to have answers this time, okay? And anytime you have a parabola, which is that quadratic shape, most likely you're going to have two answers. All right, so when you're looking at this, it says x squared minus 2x equals 15. The first thing you need to do is set this equal to 0, which means that you need to subtract 15 to both sides. Okay, this needs to be 0 over here, so that will go away and become 0, and then you would have x squared minus 2x minus 15. Now please keep this in descending order so that way it is set up so you can factor it. Alright, so there's your equation, set equal to 0. Then you're going to factor. Alright, let's go back over the rules. This is a type 1 factoring problem, which means you go right to the bubbles, and there's a minus in the back that means different signs. You split up your variable, and then you say factors of 15 that subtract to b2. Okay, remember our little table, factors of 15 that subtract to b2, 5 and 3. Well, which number is bigger, 5 or 3? Of course, 5. 5 will then get the sign right here. So 5's got to be negative, and then the 3's got to be positive. Okay, so these are our factors, as you can see. Then you're going to take each one of these factors and set it equal to 0. So you're going to come down here and you're going to write x minus 5 equals 0, x plus 3 equals 0, and solve it for x, which means you're going to be moving the negative 5 over by adding. You're going to be subtracting the 3 over, and then you'll end up with x is 5 and x is negative 3. Okay? So what that means is if you plugged in 5 right here, let's go ahead and do that. That would be 5 squared minus 2 times 5 minus 15. Does that equal 0? All right, 5 squared is 25 minus 10 minus 15. Does that equal 0? Yes, it does. 25 minus 25 is 0. And that's what the whole point of this is. It's the zero product property. Once you find your answers, if you were to plug those two answers in, it would make the statement true. Okay, same would happen if you plugged in a negative 3. So our solution set, or our solutions, are negative 3 and 5. These are also called zeros, roots, x-intercepts, and solutions. You need to know these terms. They are used interchangeably, and they will assume that you know which each one is. It's all referring to the same thing, so make sure that you know all those things mean the same thing. Zeros, roots, x-intercepts, solutions. They're all talking about where that parabola crosses the x-axis. Okay, these points where it crosses, right here, right here. Okay, all right. Now we're going to take that information that we just found, and we're using the same equation. We found that the zeros was negative 3 and 5, and we're going to graph it and see what it looks like. Now, I've already went ahead and put the work back up here because we've already did it in the other slide. So I'm going to go ahead and graph it. I know that I'm going to have a 0 at 5 and negative 3. So I can go ahead and put those dots on here. 1, 2, 3, 5 right here. There's a dot. And then at negative 3. Okay? I know for sure that's going to go through there. Now, do you remember how to find the y-intercept? Because that's always the easy problem to find. You plug in 0 for anything and then you solve it. This would be like f of x, which is the same thing as y, equals. So if you plugged in a 0, you would get y to be negative 15. That's your y-intercept, so that would be at 0, negative 15. You can always put that dot on here. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right here, hopefully, if I counted correctly. Okay? All right, so we can also go and plug in different numbers and find the other parts. But remember, you can go to your graphing calculator. As soon as I get mine up, hold on, and type it and get your points. So that's going to be x squared minus 2x minus 15. All right, so x squared minus 2x minus 15. And then you go to the table, which is second graph. And I'm going to get where you can get all the points. All right, at 0, you have negative 15. At 1, you have negative 16. So remember, our y-intercept was 0, negative 15. All right, and then we have negative 3. Let's see, let's go ahead and do our points. 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, and let's get those points. So that's going to be at negative 1, it's going to be negative 12, and at negative 2, it's going to be negative 7, and at negative 3, it's going to be 0, and negative 1, negative 16, which is the vertex. This should be right there. 2, negative 15. Whoa. 3, negative 12. And negative 7. And then 5, 0 should have that right here. And so then it goes, if you'll notice, it goes backwards. If you find the vertex, it always goes backwards. Where it's 15, 12, 7, it goes 15, 12, 7, 0. And then at negative 4, it's going to be 9. Okay, and then you can graph some of those points. Vertex is always a good one to do, and remember that was the 1, negative 16, that would be right here. And remember, it is symmetrical. So I have enough points now to draw my parabola. So I'm going to draw, oops, not quite. Okay, there's my parabola. Thankfully, we have calculators that make them a lot nicer, right? All right, so where does a graph cross or touch the x-axis? The graph crosses or touches at -3 and 5. Okay, those are your roots, your zeros, your solutions, your x-intercepts. Notice how they are opposite from what's inside those parentheses. So if you notice that the factors are the opposite of what the solutions are. And if you can do that and go back and forth, you'll be able to go through this entire chapter without any problem. All right? And then the next thing we're going to do is go backwards from either the solutions or the factors. They can give us either one. So what's an equation that would have the solutions of 3/4 or -2? Well, once you have these are solutions, so we're going to have to find the factors first. Okay, if they give you the factors, then you can just start with the step after the factors down here. So if you have the solutions, you have to start here. But if you have the factors, you can start down here. Okay, factors are a shortcut. All right, so let's take this x equals 3/4. Now, how in the world can I make that into a factor? Well, the first thing you want to do is when you read this, it's really x is equal to 3 divided by 4. Okay, the last thing I said was divided by 4. So that's going to be the first thing you do when you undo it. Okay, if you're dividing by 4, I can get that out of there by multiplying both sides by 4. So I multiply this by 4 and this by 4, which will make the 4's cancel, and it's just 3 over here. So this ends up being 4x equals 3. Okay, now I have this other one that's already in that format. It's not in a fraction, so I'm down to here. So I wrote them down. Okay, now we're going to set each equation to 0. So unless you have a fraction as one of your solutions, you can go right to this step. But if you have a fraction, you have to fix it first. All right, so now we can set each one of these equal to 0. So that'll be 4x minus 3 and x plus 2. And then these become your factors. Okay, so you just put a parenthesis around it and chop off the equal 0 to the very end. Okay, as we did right here. Now, to get your equation, you must distribute or use the box. Okay, so let's put this in the box method is x plus 2, 4x minus 3, and we multiply. So we end up with 4x squared, 8x, -3x, and -6. And then you want to look diagonally to see if anything matches up, and it does. We have 4x squared then, and then 8x minus 3x makes 5x, and then minus 6. So your equation is this. So now we are going backwards from finding the solutions to finding the equation. And you should be able to take the equation and go backwards and find the solutions too. So it's very helpful to do that because it helps you, depending on what they give you, as to how you can solve it and then graph that problem. Okay? So be able to work backwards and forwards on this. We're going to practice a lot in class. But I think that's all I have on this slide this time. Yep, I was wrong. All right, so I will see you in class. Have a good day.